Hello everyone, I hope you can all see me okay. And I just want to thank everyone for joining us today and I want to welcome you to our first UK-wide virtual James Dyson Award presentation. My name is Rumyana and I'll be your host today. So I think we're just on time and I'll share my screen with you now. Okay, I hope you can all see my screen okay. So I'm a design engineer here at Dyson, and I'm also a James Dyson Award ambassador. And today I'll talk to you about the James Dyson Foundation, early careers at Dyson, and of course the James Dyson Award. And I'm also joined by Lucy Hughes, who is the 2019 international winner of the award, who will talk to you about her invention, her experience winning the award, and how this has helped her kickstart her career. I just want to mention that if you have any questions throughout the presentation, please feel free to drop them in the chat section of the live event. And at the end of the presentation, Lucy and I will do our best to go through all of them. So I'm here representing the James Dyson Foundation, which is Dyson's charity that exists to inspire the next generation of engineers. And this is an important mission because we face a shortfall of engineering graduates around the world. The foundation goes into schools and asks students to draw what they think an engineer looks like. And a lot of the pictures that come back to us look like this: a man in dirty clothes fixing appliances. And whilst this is a valid form of engineering, it is not the only form. And we want young people to know about the diverse and exciting world of engineering. The foundation provides free engineering educational resources and runs workshops led by Dyson engineers to introduce young people to the exciting world of engineering. And alongside this, the foundation also supports charities which are local to Dyson offices around the world, and it also supports medical research. The foundation also runs the annual international design competition, the James Dyson Award. The foundation operates in the UK, the United States, Japan, Malaysia, Singapore, and the Philippines. So all the countries you see highlighted in orange. And the orange and blue combined together make up the 28 countries and regions where we run the James Dyson Award. Before I proceed with more information about the award itself, I will tell you a bit about my journey to Dyson and what my work as a design engineer consists of. So I graduated from Loughborough University with a degree in industrial design and technology. And my journey to Dyson began at New Designers in 2019, where I was invited to apply for the position of a graduate design engineer. And after several stages of the interview process, I joined the company in September of 2019 as a graduate design engineer and part of the new product innovation team, or what we call NPI for short. And this is kind of our more upstream design and engineering team we have here at Dyson. So the NPI team is made out of people with talent in different areas, including electronics and mechanical engineers, product and industrial designers, as well as researchers across all categories. So we are keen to have students from all of these areas join us. In the new product innovation team, we start with an idea and we develop our ideas through ideation, sketching, series of CAD models and prototypes. And we focus heavily on usability, performance, and finding something that can make a really positive change in the users' lives. Much of the James Dyson Foundation's work and resources are based on the engineering processes that Dyson engineers practice in our daily work. And the engineering ethos of Dyson is something that we also use to judge what makes a great James Dyson Award entry. So at Dyson, we have over 6,000 engineers and scientists, and they work in research, design and development, or what we call RDD for short. And this is really the heart of Dyson. It is where we conceive ideas and concepts, we research and experiment, We prototype, we test, we refine our prototypes, and then we test again. And this is where we develop technology that solves real-life problems. Before I talk to you more about engineering at Dyson, let's start with a global update of where Dyson is today. Okay, so to give you a bit of a breakdown of what Dyson looks like in numbers, we have over 100 million Dyson owners across all of our products and categories. As I mentioned earlier, we have over 6,000 engineers and scientists. We have 150 undergraduate engineers who work around 3 days a week with us. We span across 83 markets. We have over 10,000 patents, and one machine is manufactured every 2 seconds. Dyson's research and development teams are based all over the world, and some of the things we focus on include hardware and software development, robotics and vision systems, as well as batteries research and development. And our new product innovation team is based in the Malmesbury office here in the UK, very close to the Lavington and Bristol offices. Dyson's global footprint spans across several main sites, which include Lavington, where we have our environmental care and robotics teams, the Shanghai Tech Center, which is the first dedicated research, design and development space in China, and it has software and machine teams dedicated to research into air quality. The Malmesbury office is where we have our new product innovation and new product development teams, as well as battery labs and prototype production. The Philippines Advanced Manufacturing Site launched a motor manufacturing line in 2016, and now we're growing our software presence there as well. And we first established our presence in Malaysia in the year 2000, and we now have over 1,200 employees there working at the Malaysia Design Center. So how did Dyson become a global technology company? Well, it all started with the vacuum cleaner and James Dyson's first invention, the dual cyclone technology, which increased the vacuum suction power and removed the single-use consumable, which is the vacuum bag. And not many people know this, but vacuum bags actually contain polypropylene, which is a type of plastic, which ends up in landfills once the bags are no longer needed. Over 5,000 prototypes later, James created the Dyson DC-01, which is the first bagless vacuum cleaner. The Dyson DC-01 is now an iconic design, as it was also the first vacuum cleaner to actually show the dirt and dust collected in our homes. And to this day, it still wins awards for its design and engineering. And Dyson has continued to disrupt both their designs and core technologies over the years. So if we have a look at the evolution of the vacuum cleaners, they have gone from corded, bulky machines to light, efficient, and cord-free machines, such as the Dyson V11 you see on this slide. And these machines are a fraction of the weight. They use fewer materials and energy, but offer the same performance. The design process practiced at Dyson allows these improvements in technology to be made, and everything starts with a problem. And Dyson engineers think of ways to address this problem by developing a cycle of ideas. And these ideas are tested to see what different waste problems can be tackled. And inevitably, more problems and frustration will be met along the way. But the educational effect of this cycle of mistakes is huge. And engineers learn from what works, but also from what doesn't work. And this helps us when developing each next prototype. For example, you should all know about the Dyson Supersonic, and you see it like this. However, it took quite a while to get to that finished stage, and these are just 11 out of the unique 600 prototypes that were made out of cardboard, plastic, and metal over the period of 5 years. And each prototype was tested, faults were identified, and then improvements were made for the next prototype. And when they're laid out like this, it looks like a very linear process, but it doesn't always happen in a nice consecutive order. Over the years, Dyson engineers have solved lots of different problems following this design process. And for example, our air blade technology in our hand dryers dries hands faster in a more hygienic way and with less energy consumption than conventional warm air hand dryers. Our purifiers improve indoor air quality, ensuring your homes are safe and clean. And Dyson Lighting, which was founded by Jake Dyson and joined Dyson Technology in 2015, develops light quality that can last decades. So you can see using these iterative design processes, Dyson engineers are continuing to evolve technologies and make better machines that solve real-life problems. This problem-solving mentality informs our annual international design competition, the James Dyson Award, challenging engineering and design students to design something that solves a problem. In the following slides, I'll talk to you about the James Dyson Award, the prizes, and I'll give you some tips on what we're looking for in a winning entry. The brief for all entrants is design something that solves a problem, and the best entries and those that win put the problem they're solving at the forefront of their design. To give you a bit of a breakdown of all the prizes we offer this year, we have 28 national winners, one from each of the countries where the James Dyson Award is run. So each one of the national winners will receive a prize of £2,000, and each one of these countries also comes up with 2 national runner-ups. Out of this pool of national winners and runners-up, Dyson engineers come together and they select the international top 20 shortlist. Out of the top 20 shortlist, we are going to introduce 2 international runners-up who would receive £5,000 each. And again, out of the top 20 shortlist, James Dyson himself would pick the sustainability winner and the international winner. Both of them will receive a prize of £30,000. And in addition to that, the international winner also receives £5,000 for their university. However, it is not just about the prize money, and the global media exposure is what can really help you to boost your profile and may help you secure further investment. This is the second year of the Sustainability Award, and this video introduces James Dyson's reasoning for introducing the Sustainability Award to the competition and outlines what we're looking for in a sustainability winner. these were the 2020 international winners. The overall international winner was the Blue Box from Spain, and it is an at-home breast cancer testing device that uses a urine sample and an AI algorithm to detect breast cancer via a user's app. The sustainability winner was Aurus from the Philippines, and this is a new material that is made from upcycled crop waste that can capture UV light and convert it into electricity. And it can be attached to pre-existing structures, such as tall buildings and windows, to generate electricity. The international runners-up was Scope from Canada and the Tire Collective from the UK. Scope is a new form of camera lens that uses liquid crystals and electricity to automatically tune the camera lens to allow for greater focusing and picture quality. And the Tire Collective is a device that attaches to vehicle wheels to collect microplastics that are released from the wheel when it is in use to decrease microplastic pollution. Indeed, 65% of past winners and 20% of all winners have launched their Ryan, who was the 2017 UK winner, was inspired by James Dyson presentation like this one to be more creative in his final year project as an aeronautical engineering master student. And he submitted his invention Petit Pli to the James Dyson Award, which is a form of child clothing that uses technology which allows the clothes to expand as the child grows. And this reduces waste in the fashion industry. Since winning the award, he has founded Petit Pli as a company. And as mentioned earlier, I have the pleasure of having Lucy Hughes with me on the call, who is the 2019 international winner. And she'll talk to you about her invention, MarinaTex, and also she'll talk to you about her experience winning the award. So Lucy, over to you.
Thanks, Rumyana. Can you see me okay and see my screen? Fab. So hi everyone, I'm Lucy. I'm the founder of MarinaTex, which is a new material made from fish waste and red algae. And it's designed as a planet-conscious alternative to single-use plastic films. And these are particularly suited for the packaging industry because it biodegrades in a home compostable environment in between 4 to 6 weeks. And as Rumyana mentioned, I also was the 2019 International UK and International James Dyson Award winner. So before I talk too much about MarinaTex, I thought I'd just give you a little bit of background about me. So this is me on the best day of my life when I got to do a shark dive. And I have been diving since I was about 12. And this was kind of where my love for the ocean was really cemented. And this photo was actually taken just after I did a 3-month conservation project, marine conservation project. And what I got to see there, it was kind of like the first time I got to see the comparison between a marine protected environment and a non-marine protected environment. And that contrast was really stark. So that really fueled me to be like, right, I love the ocean and there's something wrong with it and I need to protect it. So at this point I was like, great, I'm going to be a marine biologist. Fantastic. Unfortunately, I'd done my A-levels and I'd done maths, psychology and 3D design. So none of those set you up very well to be a marine biologist at all, but what they do set you up really well to be is a designer. So in 2015 I joined Sussex Design and kind of my design journey began, but quite quickly I realised that products had sort of become the problem and our over dependency on products had become the problem. So I sort of had a mini identity crisis because I was doing a degree that was kind of creating them. But as you can kind of imagine, actually being in control of how those products are made puts you in a really good position to change that. So very often you'll all be aware of this. In design, we value form and function. The product has to look amazing and has to work really well. But I think I realised there was something that was missing from this, and that was footprint. So for me, I think in every single design, there should be in the design brief that kind of understanding of, yes, the product has to look great, yes, the product has to function amazingly, but also we have to consider what the impact of that product is from the get-go. So when starting my final year project, I kind of was starting off with the problems of the ocean, and there isn't really a slide big enough that could display all of the issues that are facing the ocean. But I thought I would just start with two that were kind of most obvious to my project. The first is that the Ellen MacArthur Foundation predict that by 2050 there'll be more plastic in the ocean than fish by weight. So to me, that showed that there's obviously like bad product design, there's bad material design, there's bad system design, and you could argue bad infrastructure design, just a lot of bad designs. And then the second problem was that the UN stated that 50 million tonnes of fish waste is produced worldwide annually. So obviously there's a huge amount of quantities here. But also that to me was like, well, there's obviously a huge amount of material here as well. And I've got one more problem to show you, and it's a bit doomsday-y, and I'm hoping this is going to work. And I apologise, this isn't meant to kind of be scare tactics. But this should be, if it loads, a countdown to how we're going to how long we've got until we run out of fish in the sea. And if you can't see that, it's 26 years, 280 days, 10 hours, 37 minutes, and 44 seconds. So that's about my lifetime. So as in how much I've already lived. And that to me is really shocking. And you might be thinking, right, Lucy, how is this? Why are you showing me this? And your product is making something with fish. So surely you're contributing to this problem. But the fact of our sort of society is that to be able to vote in that scenario, so I want to vote for sustainable fishing, because you'll see here that it says if nothing changes underneath that timer. So for me to be able to really contribute to that change, we have to vote with our money. And this is the really important role of business and the kind of tie of business and design. So fishers have quotas that are set by the government, and yet this is still the countdown. So obviously something else needs to be done. So what MarinaTex is aiming to do is incentivize fishers to fish sustainably. So I started off at a fish processing plant, and this fish processing plant are part of the Sustainable Seafood Coalition. So they only use fish that have been caught sustainably. And if we could get all of the fishers to fish sustainably, that timer will not be as deadly and as worrying. So the ambition here is to kind of add additional value to that waste. And by adding additional value to that waste, you kind of can contribute to people acting more sustainably. So this was kind of my journey. I started off, as I mentioned, at a fish processing plant. I went to the plant and I got to handle all of the fish, the scales, the skins. And at that point, I didn't know what I was going to be using. I went there with the intention of working with waste. It could have been their polystyrene boxes, as you can see in that picture. It could have been their cardboard waste. It was just kind of, I wanted to work with waste. It just so happened that when I felt the skins and scales, and I was pulling them around, and they were so strong, so flexible. To me, there was just so much potential there. So the next step was kind of researching and experimenting. So I researched into the raw ingredients. I've found the world of proteins, and I kind of looked to nature. So I sort of understood that nature can do so much with so little. If you think about like all the different building blocks in nature, you've got like proteins and keratin and kind of chitin. And I thought, why can't we kind of move away from synthetic materials and start designing with materials that nature has kind of readily available? So the second picture there is me kind of in my student kitchen, just sort of playing around with different formulas. And this was kind of part of a sort of 3-4 month journey of me doing over 100 experiments, basically just trying to see if I could try anything. I was blending fish. I was finding binders from nature. So I was using agar, which is used in cooking. It was kind of this, it was quite nice. I think it was like this design approach of just sort of like seeing what happens and just sort of throwing it out there and just using my observational skills and just sort of understanding what happens if I put it through different environments. And it was a very kind of rapid, quick testing time. And I apologise to my mother. I had I had mouldy bits of kind of material all over the house, and I apologise to my flatmates because I had fish waste in the freezer, and it was all very glamorous. But I did manage to get it to a consistent material, and you can see it there in the kind of prototype bag. And that, I think the most exciting part of this journey was actually when I could sew it. So because that was part of one of my experiments, was just sort of like seeing how I could attach it to things, because when it was a sheet material, it sort of didn't really come alive, but it really came alive when I could sew it, because to me it showed that it could be like a 3-dimensional thing. So the story so far, I graduated in 2019. I then pitched at the PlusX event, which is actually where I am right now. This is my office space. So I got 12 months office space free. And then the next day, I won the International James Dyson Award. So it was quite a good week. And that was kind of when things really hit the kind of, I say it was rocket fuel to the project. What the award really gives you is this kind of huge amount of exposure, and obviously the funding really early on is really incredible, but also this kind of credibility that comes with the project. So the award is really well recognized and people take note when it's mentioned. So from the James Dyson Award, I then got invited to the FAO, which is the Food and Agriculture Organization, which is a body of the UN. And I got to kind of display my project there and kind of meet like-minded individuals that are kind of trying to do stuff with marine ingredients and marine materials. And quite quickly afterwards, in February 2020, I incorporated the company, which then gave me access to kind of funding opportunities. So the next slide along is CPI. These are external labs that I've been working with to conduct more research and R&D on the material. And then I won a student startup competition, which gave me a little bit more funding, but also importantly, gave me kind of the time and mental capacity to work on a business plan, because I'd obviously come from design, so the world of business was quite new to me. So being able to create like a business plan was really, really valuable. And then I also was nominated for the Beasley's Design of the Year at the Design Museum, which is absolutely bonkers and a complete dream of mine to be in the Design Museum. So that is something that I'm really proud of. And also quite recently, in fact this week, I've been filing a patent for the material. And a couple of months ago, I got it trademarked under 3 classes. So that obviously just adds protection. And yeah, currently I'm also on a program, which is the Bright program at PlusX, which is trying to basically like foster innovation. So I'm still developing the material and still kind of trying to get funding, but I'll cover a bit more about that later. So in terms of the JDA, because I know that that's kind of what you guys are all most interested in at this point, I'm glad that some of my tips align with some of Rumyana's. The first one is submerge yourself in the problem. So this is what Rumyana said about putting the problem first. I think what I did here is really understand who the problem, like what the problem was, and talk to as many people as I could that shared that passion. And for me, what that's done is not only does it keep you motivated at the really early stages, but it's also a really good way of keeping in touch with the problem and keeping up to date with the most current affairs. So the second tip is to show you're working, even the failures, I would say, especially the failures. So such an important part of the design process is working from your mistakes. And there is no design process that goes without mistakes or without failures. And that's such a key part. I think failures are the only true time that you get to see real feedback from your project. So don't hide those in your application. Be proud of those and show what you've learned from them. I think the third tip is to think beyond the project. So this is kind of more about the feasibility. So it's not just a design, like a final year project or a master's project. Think about how this would go out into the world and think beyond kind of those, that project. And then finally is take a risk. I think especially when you're in the kind of university environment, it's kind of the last time you get to properly take that risk, because if you're in a job, you're kind of answering to someone else. Like, this is the last time that you have full control over kind of a project. So I'd stretch yourself and see if you can take a risk. And then just some examples of how I've practiced what I've preached. So this was my application for the JDA. And this was one of my failures of my experiments. That doesn't look good. And then the second one, this is kind of about the feasibility. So this is about the protein yield and how much, like, one Atlantic cod, how many carrier bags that could make. So just trying to make sure that you understand that your project doesn't exist in a vacuum and it exists within kind of parameters, and that you're aware of those parameters. And then my ambitions for the project. So initially, my focus is on gaining funding. Sadly, money makes the world go round, and funding is really vital. I think what I need to do initially is grow my team, because at the moment it's just me working on it, but I want to get a chemist on board so that I can continue to develop the material. Within a year, I want to be replacing plastic. So whether that is commercializing it or just in a pilot, which is probably more realistic, I'd want to be doing that within a year. And then 10 years time, I want the project to be kind of restorative and fully sustainable in all senses of the way. So all senses of the word. So whether that's kind of how it operates and the materials that are used and the processes and the supply chain, all of that is sustainable, and I can kind of sustainably launch it around the world as well, so that this is the kind of it's a solution that can be replicated globally. And yeah, thank you very much. Good luck with your applications. I'm sure they'll be great.
Thank you so much, Lucy. That's fantastic. I'll just share my screen now. Hope you can all see this okay. Right, so entry is easy. You can enter online via the official James Dyson Award website. You must be currently studying or have graduated in the past 4 years in a design or engineering related degree from a university in one of our eligible countries. You can either enter as an individual or as a team of up to 10 people. So here is Dyson design engineer and James Dyson Award top 20 judge George Oram providing you with some hints and tips about what makes a winning James Dyson Award entry. So when you submit an entry, you will be asked to provide answers to all of the questions you see listed on this slide. And please make sure you provide clear and concise answers. The judges are particularly interested in the problem you're addressing and specifically how your invention works to solve it and how it is different to already existing solutions out there. This will demonstrate to the judges why your invention is important and worthy of the prize money. The judges are also interested in your design process, so like the one practiced at Dyson and like the one that Lucy mentioned. So please make sure to provide evidence of all of your prototyping, testing, development work, what worked for you, what didn't work. And we understand that because of COVID, some of you probably won't have access to labs and workshops to work on your prototypes. So the judges will bear this in mind. But if you can't provide any prototypes, sketches or CAD designs or renders are also great. And as George mentioned in his video, another good tip is to make a short 30-second video about your invention. Even if you use your smartphone, this will definitely capture the judge's attention. These are the key dates for the 2021 competition. They're also available on the James Dyson Award website. So entries opened last week and they would be open until 11 p.m. on the 30th of June. So please make sure you submit your projects before that. On the 25th of August, all the countries will announce their national winners and runners-up. On the 13th of October, Dyson engineers will introduce the top 20 shortlist. And on the 17th of November, we will announce the international winner and the sustainability winner. And a good tip is to save your entry as a Word document so you don't lose your work if the website gets overwhelmed with entries. Before we get on to any questions, I just want to point out that if you have any questions that we don't answer today about the James Dyson Award, please feel free to go to the James Dyson Award website, or if you can't find what you're looking for there, feel free to email the JDA support email. And for early careers with us, you can go to careers.dyson.com. And once again, if you can't find what you're looking for there, please email graduates@dyson.com. So now we can go to the questions. So if you have any questions, please enter them in the chat section now. While we wait for some questions, I have a question for you, Lucy, that perhaps would some students will find interesting. And I would like to ask you, was it overwhelming winning the award and starting a business? And what was kind of the moment when you felt that you kind of starting to settle in your mission to set up MarinaTex as a company?
Yeah, I think it was all a bit of a whirlwind. Definitely overwhelm was a part of it. And what I would really recommend to anyone that does win is like get in contact with previous winners, because they've obviously gone through the same experience. But yeah, I think I wasn't ready for the amount of kind of interest, I guess, and it was all like really positive and really encouraging. I think it was something that like really gave me that sign to keep going and like want to like make a business out of it and carry it forward. It was, yeah.
That's great. And another question for you, Lucy, is what was the inspiration for using fish waste and red algae? And was there kind of like a light bulb moment?
Yeah, so as I mentioned in the presentation, there wasn't like an intention to go and use fish waste from the get-go. The light, I guess the first light bulb moment is just when I held the fish in my hands, because I could see, I was like, there's something here, there's something in nature that is making this strong, making it so flexible. So that was probably light bulb moment number one. And then probably light bulb moment number two was when I like looked into all of the building blocks of nature, and I could kind of see that nature could do so much. So like nature does bind things, nature can waterproof things, nature can like do all of the things that we're trying to do, but not synthetically. So that kind of opened up this whole second world of like, because very often in design, you know, we've matched, I guess design and physics go hand in hand, but we've kind of overlooked like design and life sciences, so like design and biology or design and chemistry. And I think that that's kind of the movement for me anyway, of like where I see myself as a designer, is that kind of crossing those two boundaries. So that's probably light bulb moment number 2.
Thank you. I think there's another question for you. Did you find it hard to transform from university to developing your own business?
Yeah, very hard. It's also new. I think this is also why one of my tips of like submerging yourself in the wider context, and kind of getting the right people around you. So I have a couple of good mentors, and having those people that you can ask, because, you know, I barely felt like a fully fledged designer by the time that I graduated, let alone like just, you know, a business founder or a CEO. So I think that you're never going to know everything. So I think like getting a good network of people, like a support group, a support network where you can kind of ask different people different things, is really important. And yeah, that would be my recommendation.
Thank you, Lucy. We have another question. Does a project have to be 100% complete for submission, and do you need working prototypes? It's okay if your project is not 100% complete. We're not looking for 100% complete products. We just want to see that you've put time in developing different prototypes, you've considered different areas for further development, and work in progress is absolutely fine. I think this is what the judges are expecting to see. So don't worry if it's not fully resolved, or it's not even like halfway through. I think that's to be expected. There's a question that I think Lucy would be able to answer best. Do you think in the long term reducing consumption and production is the way to go? And how do engineers reconcile this?
Yeah, I think so obviously if you're aware of like the waste hierarchy, the top things that you should do is refuse, and then you've got kind of like recycles right like kind of in the middle, and then dispose is right at the bottom. So the top ones are refuse. And I think that the best way to kind of shift this is to maybe move away from like the reliance on products or owning of the products. So there's different things you can do here. You can like design systems that involve products, but you don't necessarily own it. So it's kind of like almost like a leasing model. And I think that, yeah, it's just kind of being clever with how people use the products. And it's not necessarily that they take, you know, we take something from the earth, we make something with it, and then we dispose of it. How can we kind of keep those materials in use by kind of coming up with different ways of using those products?
Great, thank you. Thanks again, Lucy. Yet another one that you could perhaps provide a good answer to. How far into your project did you get when you were at uni?
Yeah, so at uni, I got to a point where I had made a material. It was pretty much kind of complete. I think the tricky thing here is that like I feel like a material can sometimes be always in like R&D. So it was got to a point where I could use it in prototypes. It was strong. I managed to do some tensile tests on it, and kind of get a better understanding of kind of what its properties were. But it wasn't super advanced. Like it definitely wasn't finished. Like I've still got to do work on it. I think it was just got to a point where it was showing like really positive, I guess, behaviors. Like it was stronger than LDPE at the same thickness, which is obviously really encouraging. So I think, yeah, it's just about kind of getting it to a point where obviously it's completely understandable that you've got a couple of months or half a year to work on this project. So you're not expected to kind of, you know, finish a whole project, because I don't think that's actually possible. Obviously there's got to be like loads of work that goes into actually launching a product. So I think another point I'll add is, in your applications, if there is like an elephant in the room, address that elephant and say, what, like, if I'm trying to think of an example with me, I think so, like mine was obviously like using fish waste to help fish. Some people couldn't understand the fact that I was using like dead fish to help fish survive, and people kind of thought, oh well, if you were, if you really cared about fish, you wouldn't use the fish at all. But my argument was like, you actually flip that and you involve yourself in the conversation. If you're actually like in that fish process, like if you use fish as a resource, you're actually now actively in that, because you vote with your money. So just address those elephants. Don't kind of leave it to be potentially like blown up a bit even more.
Thanks, Lucy. I think I can answer this one. How do you protect your project? It's up to all of you to secure any IP on your projects. If you want to, that is, it's not necessary for entering the award, but by entering the award, you automatically agree with the terms and conditions, and that is for your project to be public. So if you do want to protect it, that is up to you. But please, if you have any intellectual property on your project, please mention that in your entry and in your submission. Lucy, I've got another question for you. What was it like winning the award?
It was, I just couldn't believe it. I couldn't even believe I won the first award, to be honest. It was, I think the only one I couldn't use is bonkers. Like amazing, obviously, like that was sort of throughout my whole, I was always aware of the JDA award. I was always like conscious of Dyson, like that, I grew up in Twickenham, which is near to Ilpa Island, which is where James Dyson used to live. So like and he was always used as kind of like the kind of pedestal of design, of kind of reiterating and that iterative design process. So to get recognized by that person that I had always kind of held on that pedestal was just like incredible. And as I say, like the attention that came after that was very overwhelming. But again incredible. Like it's like there's no other, I don't see any other opportunity that can beat that amount, like just especially for student design projects. It was a real honor.
Fantastic. Another question is, can't applications be separate from your final year uni project? It can be. It doesn't have to be a final year uni project. We just think that usually final year uni projects are resolved to a good degree. But if you have a good idea and a project that you spend a lot of time and you think it's worthy of the prize money, absolutely feel free to enter that as well. You can enter as many projects as you want, just as long as they're different from each other and show kind of different areas of design. I have another question for you, Lucy. Is finding funding difficult?
Yes. So there's a lot of different funding routes that you can take, and each one is specific to your business. So my project is very R&D focused at the beginning, and I'm quite a way off commercialization, so I might not be looking yet at getting investment. I'm actually looking at non-dilutive funding, which means something that won't take shares of your business. So non-dilutive funding are things like award money and grant money, so from like government grants. But obviously free money is very competitive. So that is what I spend a lot of my time doing. But there are other options. There's obviously like different types of investments. There's crowdfunding. I think this is especially good if you've got a product like that you can kind of give, a rewards to the people that back you early. That might be a good route for you. But I think some different types of funding have different levels of difficulty. So obviously, like the early, like the awards and the grants are very competitive, but I've had a lot of interest from investors. It's just I don't want to dilute the company yet, because I've still got quite a long way to go. So if I kind of start giving away chunks of my company now, by the time it comes to actually kind of commercializing, I might not have any company left. So it's all about kind of finding out the right types of funding for you.
Thank you. Got another question for you. How much do you expect a MarinaTex bag to cost compared to a regular bag?
Yeah, so these are really hard questions to answer at this point because because we haven't optimized production yet. So without knowing what the kind of running costs of the optimized production are, we can't obviously give an idea of how much a sheet is going to cost. The predictions that I've done, that I had to do for my degree, is that when you compare the processes, so the process that I use in my kitchen, none of the temperatures go over 100 degrees. Whereas when you compare that to plastic, even to extract the right chemicals from the oil, you have to take it up to 180 minimum. So, and that's before you've even made it into a product or made it into a sheet of plastic or a pellet. So there's a lot of energy intensive processes that go into plastic production. So when you compare that with MarinaTex, which is a lot lower energy intensive, it's looking promising.
I have a question about how you were able to prototype the material at a university.
Yeah, so I brought my own little lab set to uni. So I had my little stove and my little beakers, because they wouldn't let me in the chemistry department. So it was very DIY. And even so the facilities that they did have at uni were the tensile test machines, but they were in the engineering department and they weren't set up for plastics. They were set up for metals, so the machines weren't sensitive enough. So the uni weren't able to support a lot, but I think it just sort of demonstrates, I think the only support that I really needed was them to support the project so that they weren't going to fail me on making a material rather than a product. And I think if you've got that drive and the ambition, if you think you're onto something, you should just try your best to kind of, because I managed to find a tensile test machine that was sensitive enough. Like the resources are out there, but I understand not everyone has a huge budget. At our university, we got £290 towards the project, and I think my thesis, we had to print our theses, and I think that cost like 170. So I was left with like 120 to do this project. So luckily I had a job at the same time, so I could kind of pitch in for that. But yeah, I think it's just about being really resourceful. So, and I'll stop rambling, but one more point. So I couldn't obviously do like, I wanted to test how the material, like how air passed through it. And in a lab, you'd probably pay like a couple of grand to get that done. But I kind of ad-libbed it and got different jars of hummus, and I put different materials over the tops of the hummus and I watched it oxidize. So it's just about kind of using observational techniques, and especially you guys trying to do these projects during coronavirus, like it's really tough. So I think just try and be as resourceful as you can, and I think that will really show through. Like if you can kind of think about how you can get ways around it, that you don't need to have the best equipment, how can you kind of show that on a budget and kind of answer those questions.
Great. I'll direct the next question to you again. Do you see design as the answer to sustainability to change longer term consumer behavior, and do you think this is achievable?
Really big question. I think I think design is crucial. I don't think it exists, as I said earlier, in a vacuum. I think there needs to be changes across every single sphere. There needs to be behaviour change, there needs to be like governmental change, there needs to be business change. But I definitely think that design plays a huge role, but it's about giving those designers more of a platform, because very often designers will go into jobs which they aren't necessarily the product. They design the products, but they're not necessarily the ones that are in touch with the consumers anymore. They're very much the product people. So the people that are in charge of understanding what the parameters are of the project, they need to be the ones that are also championing sustainability. So to do that, customers need to want sustainable products. Governments need to be putting pressure on the businesses. Like, as soon as you have pressure from every side, that's when change is going to happen. I think if you've just got pressure from one side, that's not enough. So I think design does play a crucial role, but it's not the only piece of the puzzle.
Thank you, Lucy. We have a question about whether you can downscale the version. Can you have a downscaled version as a prototype? That's absolutely fine. If you're prototyping or if you're designing something that's quite large, but you can't possibly make a prototype that's one-to-one scale, absolutely, that's fine. Feel free to show us how the idea works and your process and kind of what the larger picture is. It's absolutely fine to play around with the size of the prototypes. I think we might have time for only one or two more questions. Lucy, if you're happy with that. I have one more for you. Will you try to make plastic with 3D printers?
Yeah, so the way that the material is made at the moment, it's not a thermoplastic. So we're looking at kind of different types of processes to plastic. So even though it looks and feels a lot like plastic, it doesn't behave plastically. So that obviously comes with a different set of challenges. So at the moment, we're not looking to 3D print it, but there are other like biomaterials that are able to be 3D printed. So there's kind of looking at mussel shells and chitin. There are other ways to 3D print, and also like the whole world of like mycelium and fungi. I also want to just say that like I don't think that MarinaTex is like the silver bullet that's going to solve everything. I think it's like one of the many needed alternatives, but it's not the only one.
Thank you so much, Lucy. I think we're kind of running out of time here, so any questions that we didn't really get to today, we'll get back to you on that one, and we can also send a recording of this video to your email. So I just want to say thank you so much to Lucy for joining me today. It's been fantastic, and I'm sure that our participants will agree that you've provided some really, really useful insights. And I also want to thank everyone that signed up for this presentation and joined us today. We had quite a lot of people sign up for it, so thank you so much for your time, and I'm really excited to see all of your submissions. So I'll give you this 1 minute of your lives back. Thank you for joining us.
Thanks, guys. Best of luck.
Bye, everyone.